Hi guys, Miss Malik here. Today we're going to look at exercise 4E and it's about cubic functions and drawing sign diagrams. So the first thing they're asking us to do is to draw a sign diagram for the expression x cubed minus 4x squared minus 11x plus 30. So first of all we want to find one factor so that we can do the long division with the polynomials. So I've substituted in p of 2, so where x is I put 2. And by doing that, I end up with 0. So that means that x minus 2 is a factor. So notice that 2 minus 2 is 0. So the 2, p of 2, means that your factor will be x minus 2 rather than x plus 2. We use long division to find the other two factors. So by dividing x minus 2 into our x cubed minus 4x squared minus 11x plus 30, we end up with three factors of x minus 2, x minus 5 and x plus 3. You can look at one of the previous videos on long division if you need to see how that is done. Now, what we want to know is, does our graph look like that or does it look like that? So we've got a factor of x minus 2, so there must be a value of 2 on one of the x-intercepts. One of the x-intercepts will be 5 and one will be negative 3. We don't know which way our graph will be drawn though. It's where a sign diagram comes into play. So, let's see. Let's see what happens between negative 3 and 2. We can see that there will be a y-intercept in there. So you could find the y-intercept in order to see that. And that's what we're going to do. So I'm going to substitute 0 into x. So 0 cubed minus 4 times 0 squared minus 11 times 0 plus 30 equals 30. Does that point exist in the second example? So see up here on the graphs there, would 0 and 30 exist here? Not likely. Really not at all. 0 and 30 can only exist in the positive area of y. So that means that this must be our sign diagram. From between negative 3 and 2, we have a positive value. Between 2 and 5, we have a negative value for x. I write x on the arrowed line and I do a plus and minus sign on either side. So really, a sign diagram is just like a number line that shows when the expression is going to be positive and when it's going to be negative. Let's do something else. Let's try doing the cubic function negative x cubed plus 19x minus 30. We want to sketch the graph using the calculator to find the values of the coordinates of the turning points. So we find that there are three linear factors of that. What I can do, I can take the negative out so that I get x minus 3 because I don't want negative x in there. Then it's easy for me to see what my x values are. Let's see what happens between negative 5 and 2. When you put 0 in, you get a value of negative 30. That means that my y-intercept is at negative 30. It also means that between negative 5 and 2, my values of x are negative. I also could have known that because there is a negative outside the equation there. So there's the sign diagram. Let's have a look on the calculator. So in the graphs and tables area, we type in our equation. We press the graph symbol there, and we end up with something like that. Now, in order to find the turning points, the coordinates of those, we go to gsolve. I go to max, and maximum obviously means the maximum value there. So when I click that, it tells me the coordinates for this point here, for that the maximum turning point. It's in decimal form. I can then do the same thing to find the minimum. And there it is. It shows me that the minimum is down here, puts a little cross on it, and it tells me in decimal form what that minimum is. Finally, I can go to the y-intercept if need be, and By clicking on that, I end up with the y-intercept of negative 30. It tells me quite easily there. So you see that in analysis and GSolve, you can find lots of things in order to solve for features of your graph. It's really handy. We're now going to look at the same cubic function with rule f of x equals negative x cubed plus 19x minus 30. But now we want to sketch the graph of y equals half of f of x minus 1. So what we need to do, we need to find what the mapping will be. So what is it that happens to your point xy when it undergoes that transformation of half f of x minus 1? So the x will become x plus 1 because x minus 1 becomes x plus 1. And for your y value, it'll be half of y, indicated by the half of f. Now we know that the three linear factors are x minus 2, x plus 5, and x minus 3. Therefore, and what we knew from our previous graph where we just sketched our negative x cubed plus 19x minus 30, the x-intercepts are 2, 0, negative 5, 0, and 3, 0. When we undergo the mapping, 2, 0 becomes 3, 0 because x plus 1, so 2 plus 1 equals 3, and half of 0 is 0. For negative 5, 0, negative 5 plus 1 is negative 4, half of 0 is again 0. For 3, 0, 3 plus 1 is 4, and half of 0 is, of course, 0. The turning points, as we found from the calculator, were 2.52, 1.88 for the first one. We just need to add on 1 for our x value, so it becomes 3.52, and then half of 1.88, which is 0.94. The other turning point was negative 2.52 and negative 61.88. Negative 2.52 plus 1 is negative 1.52, and half of negative 61.88 is negative 30.94. So there are our new turning points. And lastly, our y-intercept of 0, negative 30, well, we don't have that same point anymore. 0 becomes 1, and negative 30 becomes negative 15. So that's where that point goes to. So once we've found all that, we can then sketch our graph. And that's what it looks like there. Notice that we do want to find the y-intercept again. So we just substitute x is 0, and we find that our new y-intercept is negative 24. We would label the points onto the graph, our x-intercepts, our turning points, and that's that. That's how we would sketch that graph.